Look up at the night sky. It looks clean from here. Orderly, peaceful, a field of tiny lights pinned into black velvet. That is the first lie, because the sky does not show you the universe as it is. It shows you the universe after distance has flattened it, after dust has blurred it, after light has traveled so far that horror begins to look beautiful. And somewhere inside that deception, hidden in one of the most crowded and obscured regions of our galaxy, there may be a star so large that even calling it a star feels too gentle. A swollen red giant of a thing. A celestial body so immense that the title attached to it sounds less like science and more like a warning. Stephenson 2-18. A name most people have never heard, and yet, by some estimates, it may be the largest known star we can currently defend. Not the brightest, not the most famous, not the easiest to see, just the one that turns size itself into something sinister. Most people think the biggest star in the universe should be obvious. It should dominate the sky. It should blaze like a cosmic tyrant. It should announce itself. But the current frontrunner for that throne is buried inside Stephenson 2, a red supergiant cluster in Scutum, behind heavy obscuration among a crowd of other massive stars in a region so visually polluted by dust and overlapping light that even identifying what belongs there and what does not becomes a problem. This is not a king on a throne, this is a suspect in hiding. That is what makes this story unsettling. The mystery is not just what is the largest star, it is how could something this large hide so well? Because the night sky teaches the wrong lesson. It teaches that what is visible is what is important, that what shines the most must matter the most, that if something is truly enormous, it will reveal itself honestly. But visible light is a bad witness. Dust alters the testimony, distance corrupts the scale, crowded regions confuse the lineup, and in a galaxy, this large beauty is often just misdirection. So before we meet the monster, we need to understand what kind of creature this is. Stephenson 2-18 is not some oversized version of our Sun. It belongs to a far more unstable bloodline, the red supergiants. These are massive stars in the late stages of life, stars that have already burned through easier fuel, stars whose cores are being driven into harsher and harsher fusion, stars whose outer layers have swelled into grotesque dimensions because the internal balance that keeps them alive is beginning to fail. A star lives by argument. Gravity pulls inward, fusion pushes outward. The star survives only because neither side has won yet. But in red supergiants, that argument becomes unstable. The structure loosens, the atmosphere expands. Matter begins to drift away. The star starts losing itself while it is still alive. That is the part people rarely say out loud. These giants are not growing peacefully, they are coming apart. And we have already seen what that can look like. When Betelgeuse dimmed, astronomers were not watching a simple flicker. They were watching a red supergiant eject hot material into space. Hubble traced that material moving outward, cooling into dust, and forming a cloud thick enough to hide part of the star's surface. For a while, the monster dimmed behind its own wound. That matters here because giant stars like Stephenson 2-18 do not merely shine. They shed. They convulse. They puff out gas and dust. They leave forensic evidence all around themselves. In some cases, the thing you are trying to measure is actively manufacturing the fog that prevents you from measuring it correctly. So now we come to the number, the one that sounds impossible even when whispered. Some sources place Stephenson 2-18 at around 2,150 times the radius of the Sun. Not diameter, radius. If that estimate is right, then this star does not merely dwarf the Sun, it humiliates it. It turns our star into a technicality, but here is where the story becomes darker, not clearer. That number is tied to distance. And distance in astronomy is a treacherous thing. Change the distance and you change the size. Improve the measurement and the giant can shrink. That is why the crown of largest known star keeps changing hands. Not because the stars themselves are changing that fast, but because our ability to measure them keeps exposing how provisional our confidence really was. ESA. This is where science starts to feel like a thriller. Because now the suspect has motive, witnesses, and contradictory evidence. Gaia, ESA's mapping mission, measured the positions and motions of nearly 1.7 billion stars, giving astronomers the precision needed to redraw distances across the Milky Way. And when distance changes, legend changes. Old record holders fall, famous names lose their crowns. A star celebrated for years as the largest can quietly become smaller under a better map. That is the kind of throne Stephenson 2-18 sits on. A contested one, a crown surrounded by error bars. A title defended not by certainty, but by the best evidence we have so far. And still, even with that uncertainty, the scale remains monstrous. Because if a star like this replaced the Sun, the inner solar system would not be affected. It would be erased. Mercury gone, Venus gone, Earth gone, Mars gone. The old map of home would stop being astronomy and start being anatomy. The planets would no longer orbit outside the star. They would exist inside its swollen dominion. Familiar distances would become interior layers. What we call orbital paths would become weather buried in the body of a dying giant. And even farther out, the horror would continue. Because when a star reaches this scale, it does not become majestic, it becomes territorial. It turns space itself into a hostage. It redefines the meaning of near and far. It drags your instincts out past their limit and then keeps going. And this is only the beginning. Because size alone is not the most disturbing thing about a star like this. Its future is. Massive stars do not die gently. As the core keeps fusing heavier elements, it moves toward an iron endpoint. And iron is where the bargain breaks. Fusion no longer gives enough energy back. The outward push weakens. Gravity feels the hesitation. Then collapse begins. Fast, violent, final. In less than a second, the core can give way and trigger a supernova shockwave powerful enough to tear the star apart and fling its remains into space. And when that happens, what remains behind is not consolation. It may be a neutron star, or something darker, a black hole. That is the destiny hiding inside the largest visible things in the galaxy. The possibility that they end not as grand suns, but as collapsed remnants, as gravitational traps, as scars. The biggest thing in the story may become one of the darkest. But before the end, there is one cruel twist. Aging giant stars can create temporary zones of false hope. NASA's work on post-main sequence habitability suggests that as a star swells and brightens into its giant phase, the habitable zone can move outward. Worlds that were once frozen wastelands may briefly thaw. An icy moon, a distant rocky planet, a world that spent ages locked in darkness could suddenly find itself under a red sky with conditions mild enough for liquid water. Picture it, a cold outer world waking up, ice breaking, dark oceans breathing, red daylight spilling across a surface that was dead for eons. It looks like salvation. It is not. Because around a star like Stephenson 2-18, any Earth-like refuge would exist on borrowed time. The star is unstable, the system is violent, dust and radiation would haunt the sky, and the very light making that world habitable would come from a star already approaching failure. A paradise in a countdown. A beautiful place lit by a dying villain. If you're still here, then you already feel what this story is really about. Not just scale, not just records, but the things the universe hides behind beauty. So if you want to keep going deeper into these cosmic mysteries with me, subscribe now, stay with the story, because the farther we look, the less innocent the sky becomes. And yet, in all this violence, there is a second truth. A colder, stranger hope. These stars destroy themselves, yes, but they also create what comes after them. Massive supergiants expel heavy elements into space, carbon among them. The building material for future stars, future planets, future chemistry, and in time, future life. The same type of star that swells into instability and ends in catastrophe helps seed the galaxy with the ingredients needed for oceans, atmospheres, and living worlds. Hope does not live beside the monster. Hope lives in the debris it leaves behind. And humanity has begun piecing this together like detectives arriving late to an ancient crime. Gaia redrew the map. Hubble caught a giant star blowing part of itself into darkness. Webb found red supergiants so dusty they were practically hiding in plain sight before exploding. And ESO's Very Large Telescope Interferometer gave us a close-up of WOHG 64, a dying giant wrapped in an asymmetric, egg-shaped cocoon of gas and dust, warped enough to suggest that even at the edge of death, these stars refuse to stay simple. That image should haunt this entire story, because it shows what giant stars really are up close. Not perfect spheres, not symbols, not peaceful lanterns, but unstable, shedding, distorted bodies already halfway into disaster. So no, the real ending is not, here is the biggest star. The real ending is worse. It is this. Here is the biggest star we can currently defend. For now, because the universe does not reveal its extremes cleanly. Our maps are partial, our sightlines are compromised, our measurements improve, and old certainty dies with them. Stephenson 2-18 may be the current frontrunner, or it may be one more name in a long history of temporary kings. Either way, it has already told us something we should not forget. If something this enormous can remain half hidden in our own galaxy, then the real terror is not the giant we found, it is the giants we have not. There are hundreds of billions of stars in the Milky Way. We have measured many, we have catalogued many more, but the sky is still full of dust, distance, and concealment, full of rooms we have not entered, full of monsters that have not yet been properly named. So the next time you look up and the stars seem calm, remember this. Calm is what distance looks like, and if you want to keep returning with me to the places where the map thins out, where the measurements tremble, where the universe stops looking beautiful and starts looking honest, subscribe, not because we are finished, but because we have barely begun.